Hi there, and now I'm showing you the code behind the enrichment entangler project. This project was made in Game Salad, a great project for rapid prototyping and also for making really nice, visually stunning interactive projects that involve sound, that involve touch, that involve visuals, that involve movement, really anything you want to do with it. It's, like I mentioned in other videos of this nature, sort of like a not as useful version of Unity, but much quicker to get things done and look nice. So this is the quantum enrichment entangler. And this is how it works with the code behind the scenes. So I have open here on the screen the human side, what you see with the human controller. But of course, the way that this project works is that it's sending information backwards and forwards between two sculptures, one that the human is involved with and one that the bats are involved with. And it's not just sending the information one way like the interfacing project does, it's sending information both ways. And the information that it's sending is a range of different audio snippets that I collected myself, that are the type of audio that is considered enriching for flying foxes in care. And that gets sent both ways. So when the bats are playing with their sculpture, the human will hear those sounds and vice versa. I started off by trying to use microbit to create this project, but there was a real limitation on the amount of audio that could be sent and the way that it could be randomized. That didn't used to be the case, I think, with microbit, but more recently with the ruining of Flash, evidently a lot of the things that work on microbit no longer work. Why they were attached so closely to Flash, I don't actually know. So this way I can send a lot of different sounds and I can just control the way that it works so much better. So this is how it works. Basically, we've got our bat controller, our human controller, the picker, which tells you whether you're, human or not human. And then there's a main overall controller that's trying to figure out what the movement is of each of the sculptures. Now, if you can imagine the way that that sculpture works that the bats are touching, when they touch it, it starts swinging. And so I thought I need to make something that takes that action of swinging and can also know the difference between big swinging and smaller amounts of swinging, and can turn that into something that says, oh yes, I'm being played with, I'm being touched. So that's essentially what this is doing here. But because, of course, both are in the same game, if you like, it's the same app that runs both the human and the bats, I need to be searching on one for the bats doing the swinging and on the other for the humans doing the playing, which isn't just going to be a swinging motion. And indeed, when I first started this project, and you will see this in a lot of the footage of it, it's meant to be held sort of like a baby is held. So it's being held on its side a lot. And so that's obviously a very particular accelerometer movement, also of swinging, but almost more like baby cradling. So, you can read into that all the sorts of anthropomorphism that you like. But that's the way that I wanted this project to work, so that we had that connection between sort of the holding of a child and the holding of a baby bat, as you can see here, wrapped up in its little mama roll. So if I go to, for instance, the bat controller, we can see that it's triggering from a table, and it's sending that, if it can get it to scroll down, it's sending that to a Firebase server online. And these are all the different sounds that it's sending. So obviously it doesn't send them all at once, but here are the different sounds. And it chooses one of these at random, as you can see, self.random. And there are 8 potential sounds that it can send. And it chooses one of those at random, obviously only when it's been touched. And it will send that over to the human's device or the human's sculpture. It also has a little thing here saying record the time the sound was played at. It does that so that the sounds don't start to overlap each other. If it's starting to get played with a lot, I don't want lots of sound to occur and having it start to overlap each other. I don't want it to become something that's actually overwhelming for the bats. So if we have a look at the different tables here, that's our bat swinging table. This is just the one that sends it online. Oh my goodness, there's a creature climbing up my shirt. Sorry about that. Here we have a table that shows the duration of each sound. And so it's keeping track of what that duration is. You can see this one is the white noise sound, which goes for about almost 30 seconds. That one's quite long compared to the others. Some of them are very short, some of them are longer. So it takes note of that duration and it says, okay, let's not play another one until after that. And then that's the human one sending to the server as well. Oops. So these are just the different scenes I was showing you here, the human scene. And so basically that's how it works. It takes that swinging motion and it sees that as sort of a gentle swinging backwards and forth at the bottom of the sculpture, and that's what it thinks of as the bats swinging the toy. Because this works both ways, it does the same thing, excuse me, the other way as well. So on the other way as well, this is the human controller. It's also sending sounds as well. So if they get sent both ways, and they are the same sounds. And the same thing happens again where it doesn't want them to send too many sounds or become too overbearing. Now what this actor is showing here called increment is that actually it might be easier to show it to you this way. Here I am in the bat scene showing you how this increment actor works. So obviously that looks like nothing there. So if I click on preview, you'll be able to see this is what's going on behind the scenes on both screens. So you could see on the other one, there was the little bat picture on the screen. But this is what's going on underneath that. And it's also going on the bat's side. So if you were to open up that bat sculpture and look at what's going on inside it, this is what you would see on the interface inside it. It knows when the last trigger was of both the bat and the human. It's telling you both, even though, of course, that one sculpture is only dealing with one. It will know both of them because they're talking to each other. Anyway, the reason why I wanted to show you this is that I have here the ability to, on the screen, change where the swing factor stops. And the reason why that was important to me was that because this is an interface that's being put inside the sculpture, which personally I kind of think is quite a clever way of doing this, rather than using all smaller bits, it's all self-contained inside this secondhand phone. And the reason why I like the fact that I can change these is because it means that I can adapt it to the situation at the time. The bat's playing with it too much and it's going off a lot. Well, maybe I can limit it a bit more if it's getting a bit too overwhelming for them. Or maybe the opposite is occurring and it's not going off hardly at all and I want it to be a little bit more sensitive. Or because I'm taking the device that's inside it in and out, sometimes when I put it inside the sculpture, it's sitting at a slightly different angle. I have like braces inside the sculptures that should keep them in place, but sometimes they are at a slightly different angle to what I would expect it to be. So I can't just assume that sort of 0.-1 is the bottom of the phone. It might be 0.95. So this allows me to make sure I can change it so that that swing is always correct. So before I finish up with this one, I might just quickly show you, in case you didn't quite understand how this side of it works. This is the screen that the human sees in those versions of the project where you can see the screen. Of course, there is that version where both of them are the same type of sculpture and you cannot see any screen-based activity. But there are other versions of this project where the human is holding a device where you can see a screen. And so this bat pup simulation is happening on the screen. You can see he's moving around a little bit on the screen and he's sort of jiggling a bit. Now, if you take your finger and you give him a little stroke on the head, he'll actually move around and he'll actually respond to that. So that was just a cute little Easter egg in those versions of this project where you can see the screen, you're actually being invited to give the baby bat a little touch and a little interaction. So within this project, really a lot of what's going on is happening within that code because it's searching for those movements and it's sending them backwards and forwards. But because not all versions of this project involve the screen, and of course the bats aren't interested in the screen particularly, so there's not much images involved in this project, just these few little ones for the human screen, and it really all revolves around these 8 sounds. Now you've probably heard these in some of the videos, but some of them So if you've ever heard that in one of the videos, you'll know that's actually coming from the toy. So these sounds are sort of distant colony noises and sounds that you might hear in a colony. And the reason why I'm using those sounds is because they're known to be used for bats that are feeling lonely and are wanting to feel like they're more involved being back in a colony. And having those colony sounds can help them feel like they're more a part of the colony. There are also these very little sounds. Hopefully you heard those. I'll play them again. They're little tiny bell sounds, and bell sounds are another one that carers will often use as enrichment for bats that are in care. I'm not quite sure actually if I've seen a lot of published research that says that bell sounds work for bats. I have seen research that says bell sounds work for horses as horse enrichment. But I haven't seen published research on that. Carers do use it and they say that it works well. So they probably use, slightly different bell sounds to the ones that I've made. And then this final sound that I'll show you is another one that's very widely used in fruit bat enrichment. And it's actually just a white noise sound. Similar to playing distant colony sounds. It's meant to make the bats feel like they're in a colony, that there's stuff going on around them, and it drowns out the more human noises that might be happening around them at the time. So it's a bit loud for the white noise. So the white noise goes for about 30 seconds and it just sounds like this. It's just a sort of a background hum that goes on. And that's one of the 8 sounds that could come out of the quantum enrichment entangler.